Hello friends, today we are going to see the video on gear trains, gear train types, and the analysis of gear train we'll see in this video. Sometimes two or more gears are made to mesh with each other to transmit power from one shaft to another. Such a combination is called gear train. The nature of train use depends on the velocity ratio required and the relative position of the axis of the shaft. When the velocity ratio is large, the epicyclic gear train is used. And depending on the shaft position, the different types of gears can be used in the gear train. The gear used may be spur gear, bevel gear, or maybe one and one wheel. You can use any of these type depending on whether to transmit the power in the parallel shaft or inclined shaft or so. Various types of gear trains, these are classified as into four types: simple gear train, compound gear train, riveted gear train, and the fourth is epicyclic gear train. The first three types of gear train, the axis of shaft over which the gears are mounted are fixed relative to each other, whereas in case of epicyclic gear trains, the axis of the shaft on which the gears are mounted may move relative to a fixed axis. In simple gear train, the only one gear is mounted on each shaft, and sometimes the idler gear is also used in between the two gears. That is the first gear number 1 here in the diagram is called as a driver, and the power to which it is transmitted, the gear number 2 is called as a driven or follower gear. The idler gear is used when the power transmission distance is more between the two gears, or it also is used to maintain the or to obtain the desired motion in the desired direction. Now here we are seeing the speed ratio. The speed ratio of the gear train is calculated as the ratio of speed of driver upon speed of driven gear. That is equal to number of teeth on driven gear and number of teeth divided to the number of teeth on the driver gear. Here you are seeing the N1 by N2 into N2 by N3 is equal to T2 by T1 and T3 by T2, or it also can be written as N1 by N3 is equal to T3 by T1. So in compound gear trains, the two gears are mounted on one shaft, and so this type of gear trains are called as a compound gear trains. So in compound gear trains, as shown in the diagram, the gear 1 is the driving gear mounted on shaft A, gears 2 and 3 mounted on gears are mounted on shaft B. The gear 4 and 5 are also compound gears which are mounted on shaft C, and gear 6 is driven gear mounted on shaft D. Here also you can calculate speed ratio as speed of the first driver divided by the speed of the last driven or follower, and here it is calculated by N1 by N6 is equal to T3 into T4 into T6 divided by T1 into T3 into T5. That is equal to the product of the number of teeth on the drivens divided by the products of number of teeth on the drivers. Riveted gear trains are the one in which the axis of the first gear and the last gear are coaxial. The gear train is known as the riveted gear train as shown in the diagram. We see that the gear 1 drives the gear 2 in the opposite direction. Since the gear 2 and 3 are mounted on the same shaft, therefore they form a compound gear, and gear 3 will rotate in the same direction as that of the gear 2. The gear 3 drives the gear 4 in the same direction as that of the 1. Thus we see that in the riveted gear train, the motion of the first gear and the last gear is like. Here The speed ratio is again calculated as a product of number of teeth on the drivens divided by product of number of teeth on the drivers. That is N1 by N4 is equal to T2 into T4 divided by T1 by T3, or the earlier diagram which is shown in the 13.4. In epicyclic gear train, the axis of shaft over which the gears are mounted may move relative to fixed axis. A simple epicyclic gear train is shown in the diagram, where a gear A and the arm C have a common axis at O1 about which they can rotate. The gear B meshes with gear A and has its axis on the arm up at O2 about which gear B can rotate. If the arm is fixed, the gear train is simple and gear A can drive gear B or vice versa. But if gear A is fixed, the arm is rotated about the axis of gear A, then the gear B is supposed to rotate upon and around the gear A. Such a motion is called as epicyclic, and the gear train arranged in such a manner that one or more of their members move upon and around another member are known as epicyclic gear trains. So the epicyclic gear trains may be simple or compound. The epicyclic gear trains are useful for transporting high velocity ratios with the gear of moderate size in a comparatively lesser space. So where the space restriction is there, epicyclic gear trains are used and used for the high velocity ratios. The epicyclic gear trains are used in the back gear of lathe, differential gears of automobile, hoist, pulley block and wristwatches, etc. Now in the next slides we are going to see the velocity ratios of epicyclic gear train, how it is analyzed, that we'll see. There are two methods which are used for analyzing the epicyclic gear train. That is, first is a tabular method and second is algebraic method. In tabular method, the table is prepared as shown here. Here the normally 4 steps are followed. In first step, the arm is fixed and other gears A and B, the gear A is rotated by 1 revolution and the anti-clockwise movement is taken as positive and clockwise rotation is taken as the negative. Here gear A is rotated by 1 revolution and the corresponding rotation of the gear B is noted, that is minus TA by TB. In second step, arm is fixed again and the gear A rotated by the plus X revolution. The corresponding rotation of the gear B are rotated noted, that is minus X into TA by TB. In the third step, the plus Y revolutions are added to each element, and in the fourth step total motion is calculated, that is for arm C it is plus Y, for gear A it is X plus Y, and gear B it is Y minus X into TA by TB. So the procedure is written down in this slide. The same procedure is explained here. The little consideration will show that when the two conditions about the motion of rotation of any two elements are known, then the unknown speed of the third element may be obtained by substituting the given data in the third column of the fourth row. So this method is used for calculating the velocity ratio of the epicyclic gear train. Now the second method is algebraic method. In this again the procedure is followed in steps. In the first step, the arm C is fixed in epicyclic gear train. Therefore the speed of the A relative to arm C is calculated NA minus NC. And the second step, the speed of the gear B relative to arm C is calculated NB minus NC, and the ratio of it is equal to NB minus NC divided by NA minus NC is equal to minus TA by TB. And from this the conditions are applied depending on what is the condition given in the problem. So here, since the arm C is fixed, therefore the speed NC is equal to 0, so NB by NA is equal to minus TA by TB. And if the gear A is fixed, then the NA is equal to 0, and this is put in the formula, and accordingly the speed or number of teeth, normally speed of the any one unknown any one gear can be calculated in the gear train. So this is a procedure. These are the two procedures which are followed for the analysis of the epicyclic gear train. So we'll see directly the problem of epicyclic gear train here in that, and that we'll see in the next video. Thank you very much. Hello friends.